Hi guys, I'm Ernest. Welcome to our channel of Sciences and Mathematics. Today we're going to look at a concept under reaction rates and reversible reactions. And basically it's going to entail the concept of reversible reactions. Now before I proceed, I'd like to welcome our new members. I'll request that maybe each of our members try to bring in a new student so that we can be able to discuss this particular concept and assist one another. So for today, this kind of reversible reaction is very relevant, especially in industrial processes, particularly in trying to maximize the yield of a desired product, in that we can be able to alter some conditions like temperature and pressure and achieve the product or the maybe quantity of the product that we desire. So in that case, we're going to use a few examples in trying to give an illustration, so that in an essence we are able to understand what kind of a reaction that we are able to refer to as a reversible reaction. So without further ado, thank you and welcome. So our discussion for today is going to entail the concept of a reversible reaction, as I've said. And I'm going to use the illustration that I've given on the board amongst other equations in order to illustrate this. So I'm going to have that one as our first point. Now suppose I heat a block of ice to a particular temperature, it will melt and form liquid water. And if the process of heating continues, then I'll attain a gaseous state of water that is known as steam. So in that particular respect, I can be able to do a reverse process, whereby if I cool the steam that has been obtained by decreasing the temperature, then I'll obtain liquid water. And if I further cool liquid water to temperatures below 0 degrees centigrade, then I'm going to obtain ice. So this particular process can be referred to as a process that can be able to make to go in either direction. So bearing in mind that maybe if I'm trying to heat this block of ice for the first route, which is from ice to steam, then I'm heating or increasing temperature. Now from steam to ice, I'm cooling, so I'm decreasing the temperature. So in this respect, we're going to see that there are some of the reactions which can be made to go either direction by changing their conditions, like the temperature or the pressure. So in this case, for our illustration, it's the change in temperature by increasing or decreasing the temperature. And we're going to see that this particular change is going to entail a physical change. We have talked about the concept of a physical and chemical change in our discussion about the concept of matter. So in this case, it's a physical change that is changing from ice to steam or steam to ice, respectively. Now there are some of the chemical reactions whereby we are going to see that maybe the changing in temperature or pressure is going to result in a reaction that is going to undergo a chemical change. And the difference between the two is basically in that for a physical change, the kind of matter that is changing, it changes from one form to another, but its chemical properties do not change in that essence. And for the chemical change, there is a change that results in the formation of a new product. So whenever we are talking about the physical or chemical reversible change, we are bearing in mind that there's a change in the physical state, but its chemical properties remain the same. But in chemical changes, there's a change whereby there's a formation of a new product. Now, for instance, in this particular two concept, our first illustration is a physical change. So therefore, from our illustration, we can be able to give a definition for the concept of reversible reactions, in that these are reactions which can be made to go in either direction, which can be made to go in either direction. So either direction in this case refers to either the forward, it proceeds to the forward direction, or the reverse or the backward direction by changing conditions such as temperature and pressure the example of which we have already illustrated on the board. Now we're going to give an example of a change that is going to entail a chemical change. Now that we have given an example of water. Now this is a word equation for the change, the physical change of ice to liquid water to steam. That one can be given in the form of an equation whereby we have water as a solid state, which is ice, and then it's forming water in liquid state, which is basically liquid water, and then water in gaseous state, which basically is steam. So therefore, reversing this, we're going to get the respective products that we have already illustrated. So this is a heating, and the reverse process entails the concept of cooling. So the reversible reactions are presented by the double arrows that I've already used on the board. But in some instances, we're going to see that there's a use of double half arrows that we're going to mention basically in details under the concept of equilibrium. So basically, that is how we can be able to illustrate this physical change. Now, suppose there's a case whereby we are having ammonium or ammonia gas that is reacting with hydrochloric gas. This is going to form a compound that is ammonium chloride, which is a dense white cloudy or substance that we're going to see later that is a solid, or maybe we can refer to it as a precipitate. Now, in this particular reaction, we're going to see that this reaction can be reversed in a sense that we are going to have ammonium chloride, which is a dense gas, maybe just a solid. It is being heated, and then we are going to have so this is a solid basically. It's going to be heated, and we're going to have ammonia gas NH3. So we're going to have ammonia gas plus hydrochloric gas in that respective order, so it's stoichiometric, so it's okay. So in this case, we're going to see that this is one of the reactions that we can refer to as a chemical reversible reaction, whereas the first one illustrates the concept of a physical reversible reaction. Now the setup that I've put on the right side of the board is one of the illustrations that we can be able to use, or maybe an experiment that we can be able to perform in a laboratory and try to determine whether the contents which are being heated can undergo a reversible reaction or not. So that basically contains the crystals of blue copper sulfate that are inside this tube B. So inside this tube B, there's blue copper sulfate crystals which are being heated. Now, after some time, in that process of heating, it will be observed that a white border will be formed. Now, basically, which in an essence means that these blue crystals of copper sulfate will be transformed into a white border, and there will be a formation of a colorless liquid in this test tube A. So that one basically implies that that particular substance that we're having inside that test tube undergoes some change, and the change entails basically the removal of water of crystallization. So there's a water of crystallization that is contained in the blue crystals of copper sulfate, which basically can be illustrated as copper sulfate. And then there's this is five molecules of that water of crystallization, and when we heat that substance, we're going to have copper sulfate plus water. So therefore, in this case, this water of crystallization, I've said, is five molecules of water. So forming that crystals, and the reaction is reversible, so it is going to form that one. So therefore, if this is these are blue crystals, after heating, it will form white powder, which is basically copper sulfate. Now, if this specific clear colorless liquid that is formed is poured back into this particular setup without undergoing the process of heating, the crystals are going to turn back into their blue color, which basically means that they have regained their water of crystallization in order to form copper sulfate crystals. So there are several other reactions that we're going to see, which are basically going to entail the concept of a reversible reaction. Like if we have a carbonate like that, and then we can be able to, if it undergoes heating, we're going to have a calcium oxide plus carbon 4 oxide. So basically this is one of the, this is a gas. So this is one of the reversible reactions that we're going to encounter among others. And even cobalt chloride and iron, maybe hydrated iron 2 oxide, which is basically rust, can be able to undergo some reversible reaction subjected to temperature. So in this case, we have said that this basic concept of reversible reactions is very much applicable in industrial processes, especially in trying to maximize the yield of our desired product. Therefore, for products which can be able to experience reversible reactions, they are very important. It's very important because we can be able to optimize the yield by trying to alter the temperature, exploiting this concept of the reactants in a sense that they can be able to be reversed from the product to the reactants and vice versa. So in this case, we are going to encounter other aspects of reversible reactions as we have talked about this. But of essence is that in any case we come a notation of course of representation of this kind of arrows, then we are going to of course refer to the concept of reversible reaction in maybe most of our discussions. So I hope from the illustration that we have given on the board, we are going to of course understand this concept of reversible reactions and perhaps apply them appropriately in case we come across them. So that is it for today. Thank you guys. God bless. Bye.